Hello everyone, I am Charishma. Today's topic is polynomial regression. What is a polynomial regression? Regression is a supervised learning technique used to predict continuous outcomes like price, temperature, score, etc. It helps us underfits the relation between input and output variables like independent and dependent. Why polynomial regression? It can handle non-linear data that curves or bends, captures complex relationships between variables. It's like an extension of linear regression by adding extra terms like x square, x cube, polynomial terms. And this is the mathematical representation of polynomial regression. And these are some types like linear, quadratic, cubic, and highly order. Linear, it has degree 1 and it's just a straight line, y equal to b0 plus b1x. And quadratic, it was degree 2, includes x square, captures u-shaped or inverted u curve, y equal to b0 plus b1x plus b2 x square. And cubic, it was degree 3, includes x cube, handles more complex bends, y equal to b0 plus b1x plus b2 x square plus b3 x cube. And high order, it was above degree 3, adds higher power, captures very wavy patterns, bends. It was too heavy degrees can overfit the data. And how it works? Step 1, transforms the input feature, including of just x. We can create new features like x square, x cube, etc. And step 2, apply linear regression. We use regular linear regression, but on there is new features, new polynomial features. Result, the model fits a curved line to the data, matches the non-linear pattern. Example, predicting house price. In the linear model, degree 1 fits a straight line and underfits and misses some important patterns. But in polynomial mode, degree 3 or 2 or 3 fits a curve, like capture the trend more accuracy, like this. And this is the Python code for polynomial regression. And these are some advantages like e-commerce websites and biology, physics, engineering, and mathematical, these fields are used. And coming to disadvantages, it can overfit the data, and interpretability, computational cost, and extrapolation danger. And these are some applications. And coming to advantages, captures non-linear relationships and still easy to apply using familiar linear regression tools, and more flexible than simple linear regression. And it can improve fit when linear model underfits. And coming to applications, uh, and this is the conclusion. Polynomial regression is powerful when for non-linear data, choosing the right degree to balance bias and variance, useful in many real-world applications. Thank you.
Is the coding part of the polynomial regression, and here is the step-by-step explanation of this. NumPy helps us with numbers and arrays, and matplotlib helps us to draw graphs, and linear regression is used to create a straight line model, and polynomial features is used to create curved data like x square, x cube, etc. And mean squared error and R2 score helps us measure how good our model is. And coming to step 2, we generate 80 random x values, and y values follows a curved pattern like a wave with a little bit of random noise added. And coming to step 3, here we fit a straight line model to the data using linear regression, and the predicted values are stored in y predict linear. And coming to the step 4, here we can create new features like x square, x cube, x power 4, because we want a curve, not a line, and we then use a linear regression again, but now the new curved features. And here is the main step of this, and the blue dots represents actual data, and green line represents linear regression result, and red curve represents linear regression results. And we will see the red curve fits the data much better than the green line. And here is the final step. MSE, mean squared errors, tells us how far the predicted values are from the real one, and lower is better. R square scores tells us how will the model fits the data, and closer to 1 is better. We will notice polynomial regression gives a much better score than linear regression. And here is the final summary. That was linear regressions draw a straight line, but polynomial regressions draw a curved line. And you use polynomial regression when your data is not in a straight line. It gives better accuracy for curved data, but don't use a too high degree. It might fit too much and because bad at predicting new data.